Dear students, welcome to HomeLearns class 11 Mathematics, Chapter 2. In this class, you will study the second chapter of Mathematics, Class 11. What about the second chapter? The name of the second chapter is Relations and Functions. We would study relations and functions. What are the relations? What are the functions? How they work to each other? What is the relation between them? Is a relation or the function are same or are they different? What is the sets? We will study all. Before going to this complete relations and functions, let's start introduction of the chapter. We know in daily life, we come across many patterns. Many patterns means such as relations, brother and sisters, father and son, teacher and student. We also come across many relations in mathematics also, like m is greater than n. M is less than n, or L is parallel to K, or we can say that A is a subset of B. All these are the relations in subset. So we know that if M is less than N, L is kernel line, L is parallel to K, A is a subset of B, it means there is some relation involves in these objects or their pairs of objects. In this chapter, we will learn how to link pair of objects from two or more sets and then establish a relation between two objects in the pair. So we will learn all about. Let's start. First of all, let's consider the Cartesian product of sets. What are the Cartesian product of a set? Set is a well-defined. What is the set? As you have studied in previous chapter, chapter 1, set is a well-defined collection of well-defined objects, and those objects must be distinct. Cartesian products of sets. What the Cartesian product? Cartesian product is the sum total of all of the values, or maybe the product, or we can say that every one element of a set belongs to all other elements. Let's consider we have a set of two colors. A is a set of two colors, and we can denote it as in the form of the set red, blue. And another set B has three objects A, B, or C. Then the Cartesian product of of these sets means how many pairs of colored object can be made through this. We can denote it as red A, red B, and red C, blue A, blue B and blue C. There will be the six distinct pairs and close with the curly braces. There are six different pairs from these two sets. There are two elements in the one set and three elements in the another set. Then there are six distinct pairs. So if we say that, we recall our previous classes, that ordered pair of elements taken from two sets. If we have two sets like set P and set Q, and these are the non-empty set, then particular ordered set is, we can say that P is the element, Q is the element in second set, then P belongs to P set and Q belongs to Q set. So Cartesian product of these two sets can be defined, or graphically we can note this as, here are the two colored object, red and blue. This is the A, B and C. Six different objects we can make. Now, if we have given two sets P, Q, these are the non-empty sets. The Cartesian product of these sets would be like this: P cross Q, a set. P is the element of P set, Q is the element of Q set, such that P belongs to P and Q belongs to Q. We can denote it in the form. But these are this condition is for non-empty sets. If your sets are empty sets, or P or Q, either P or Q has null value, P or Q is equivalent to empty, or it is a null set, then Cartesian product of PQ will also be empty. As you can think that if we multiply any number in the simple mathematics, if we multiply any number with the zero, then that comes to the zero. Similarly, if Cartesian product of two sets will be the null set if one of them is the null set. Let's consider again. I hope that you consider the Cartesian product fully with the help of this. There are two sets, red, blue. Another set is AB. So that is the ordered pairs. We note six ordered pairs. Now, for more clarification, let's consider again two sets. Let's set A. Set A has set A is shoot, pencil, pen. Set B is 1, 2, 3. what would be the Cartesian product for this? So the available pairs would be root 1, root 2, root 3. Then pencil 1, pencil 2, pencil 3. Then pen 1, pen 2, pen 3. There are 9 such pairs in the Cartesian product. Because there are 3 elements in A, 3 elements in B, then there are 9 possible codes. There are 9 possible codes. And finally, if I say that there are 2 sets having set A, set B, and graphically you can represent it as this is the pen, and this denote 3, 2, 1. This is the pencil, and this one is fruit. 1, 2, 3. Pen 1, pen 2, pen 3. You can show it with the help of a dot here. These combinations, 9 combinations. There would be 9 combinations. If we have 2 sets such that set A is equal to A1, A2, and another set B1, B2, B3, B4. Then how can we sort out this? Let's, with help of a pictorial diagram, there are 2 sets, 2 objects in set A, A1, A2. This is the B4, B3. B's element are here, B2, B1. First of all, B1 is B1, A1, B1, A2, or A1, B1, A1, B2, A1, B3, A1, B4, A2, B1, A2, B2, A2, B3, A2, B4. All these sets means total, there are total 8 sets. So 8 ordered pair formed can represent the position of points in the plane. 8 ordered pairs would be there. A1, and A2, B1, A2, B2, A2, B3, and A2, B4. 8 ordered pairs would be there from both of the sets. And all are the distinct, because we know that the point A1, B1, A1, B2, A1, B3, A1, B4, A1, B2 is A1, B2 is distinct from the A2, B1. A2, B1. Distinct point. So here from the above notations, the Cartesian product, we reach on some conclusion, and there are the some remarks that two ordered pairs are equal. This means this or this, this or this, or this or this are equal if the corresponding first element are equal and second elements are equal. What are the corresponding means? A1 B1, A1 B1, A1 B2, A1 B2 or B2 A1. Both are the different, not similar. A1 B2 is not equal to B2 A1. It means these ordered pairs, not the sets. These ordered pairs are equal if the order of their corresponding element are the same. Then that is the equal, otherwise it's not equal. First element must be equal to second. A1 B2 is not equal to B2 A1. And second remark is that if there are p elements in A, let a set P, there are p elements in A, a set has p element and q element in set B, then there will be PQ. PQ. When will be the PQ? The condition is that if and only if number of is equal to P and B set is equal to Q, then we can show that N is equal to A into B is equal to PQ. Only this condition must be satisfied, that elements of A and elements of B must be Q, then it is the Q, otherwise no. If A and B are the non-empty sets and A or B is an infinite set, so is A into B. Infinite set ho, beshak either or it is non-empty sets. And if A into A into A is equal to A, B, C, three elements, such that A, B, C belongs to A, then this set is called ordered triplet. Ordered triplet means A into A into A, and in the first A there is A element, second A there is B element, third A there is the C element, then the Cartesian product of these becomes ABC. If all ABC belongs to A, then it is called a ordered triplet. There are three element triplets. This whole about the first part of relations and functions in your NCERT books. Now let's take 1, 2, 3 examples, and before going to the exercise in this class, let's study some examples briefly one by one. Example 1 states that if x plus 1 y minus 2 is equal to 3, 1, then find the value of x and y. What is the x? What is y? As we know that in the relations x plus 1, first belongs to first, y belongs to y. Then x plus 1 is equal to 3, y minus 2 is equal to 1, and x is equal to 3 minus 1, that is 2, y is equal to 1 plus 2 is equal to 3. We reach on the conclusion that x is 2, x is 2, y is 3, the value of this. Similarly, Cartesian product, and if two sets have Cartesian product, like set 1 P and another set is Q, is PQ is equal to QP. No, PQ is not equal to QP because ordered pairs, the pair is not equal to another pair. Like as I have told earlier in this chapter, that AB is not equal to BA because order must be the same. So hence Cartesian product of PQ or QP is not equal to each other. Number of elements in each set will be the same, but their corresponding element is not same. Example 3 of your chapter, you should practice this because you have learned a lot about in your previous chapter. But one example number 4 I will do for you. Rest you will do yourself. Let there be a set. Let A set is 1, 2, 3. B is 3, 4. C is 4, 5, 6. Then A into B intersection C. Yes. A into B intersection C. B 3, 4. C is 4, 5. It means it becomes 4. A 1, 2, 3. And B 4. The Cartesian product of this is 1, 4, 2, 4, 3, 4, 1, 4, 2, 4, 3, 4. Cartesian product of this is 1, 4, 2, 4, 3, 4. And similarly, you can do others. Let's fourth part. What would be A into B union A into C? Cartesian AB 1, 2. So AB 1, 3, 1, 4, 2, 3, 2, 4, 3, 3, 3, 4. This is the A cross B. Now A cross C. First of all, we solve A cross C. 1, 4, 1, 5, 1, 6. 2, 4, 2, 5, 2, 6. 3, 4, 3, 5, 3, 6. These are the elements or ordered pairs in the Cartesian product. What would be the A union B? A union B means all the ordered pairs, excluding only which are repeated. Means 1, 3, 1, 4, 1, 5, 1, 6, 2, 3, 2, 4, 2, 5, 2, 6, 3, 3, 3, 4, 3, 5, and 3, 6. This is all about the union or the intersection and set operations on Cartesian products. Now, let's take an example of the triplets. Triplets Cartesian product, triple A. I have shown previously the triplet. Let P is a set 1, 2. Then what would be the P into P into P? P into P into P, 3 sets. We would make 3 sets. First element would be 1, 1, 1. 1, 1, 2. 1, 2, 1, 1, 2, 2. 2, 1, 1, 2, 1, 2, 2, 2, 1, and 2, 2, 2. How you would do this? Let's consider 3 sets. 1, 2. Another set is 1, 2. One more set is 1, 2. Then there would become 9 order, 8 ordered pair. Then there would be the 8 ordered pairs. One, two, like this. 1, 1, 1. 1, 1, 2. 1, 2, 1. So you can multiply with each and every bit. 1, 1, 1. 1, 2. 1, 1, 2. 1, 2, 1. 1, 2, 2. 1, 3. And this is the all about the triplets. I hope you understood the basic concepts of this chapter at the starting, and in the next video, we will do exercise 2.1. Till then, thank you.